Interfaces. Interfaces are very important parts of the C# equation. In the .NET world, interfaces allow us to do multiple inheritance, as you're going to see in the object-oriented section. Inheritance itself is going to be allowed on the class level with single inheritance only in C# in the .NET world. So interfaces are very, very important. We'll talk about interfaces in general because they are very useful. So interfaces can be used to define common behavior supported by different types in your applications and systems. So an interface, think of in terms of an interface. It's connecting something, and they're dealing with specific things. Interfaces can have smaller blocks of code, meaning that you can derive classes from multiple interfaces, so it's going to have a very specific functionality. So interfaces also support the callback mechanism and are called callback interfaces, just for your information. Now, this is what an interface is going to look like. You have the interface keyword. Public is normally what you're going to define your interfaces as, so you can use them. Depends on your access level, of course, your access modifier. And capital I is normally what you put in front for your interface. So if you see capital I anywhere, looks like a 1, but it's a capital I. That's going to be working with an interface, most likely. You're going to see a lot of interfaces as you move forward. We're going to talk about them as we get into more advanced parts of the training. You'll see them used and you'll know what they are. They work similarly to classes, of course, but they're interfaces, and we'll see why they're different. Now, an interface can have methods here. You're not actually implementing the methods here. It's more or less a contract. You're defining them here. So void started and void finish. These are two different methods that have signatures, and interfaces actually can help with event notifications, as we'll talk about later. An interface looks like a class, like I said, but it has no implementation. So big word, implementation. So implementation just means there's nothing there in the code block. There's no code block. It's only defining that signature for that particular method. So interfaces are going to contain definitions of events, indexers, methods, properties. These are the things that they're going to contain definitions for. And then later you implement that by deriving or using inheritance to work with those interfaces, and then you actually implement that afterwards, as we're going to see. These are inherited by classes, structures, and other interfaces. Classes, structures, and other interfaces will inherit your actual interface that you're creating. Now, the implementation is going to be contained in objects based on the definitions. So we're defining things in the interface. This is what things are supposed to look like, and then we're implementing things in the actual inherited thing that you're using, classes, structures, or other interfaces. So what we're doing is we're defining a contract between objects derived from these interfaces. Now, basically what I'm saying is that you implement an interface and then you use it in a class. So if we take a look at this interface here, this is the interface we created. Now here is the implementation. Colon to actually inherit. We're deriving interface implementer here, long name. We're deriving it from my interface. This is the interface, and this is going to use inheritance to actually say that this class derives from this. We'll talk about that in the object-oriented section. But here is the main functionality of this class. You can see that down below, we have one method here that we have to implement. Well, anything that you see here within the interface, you have to implement. There's no getting around it. So we have method 1. Well, we have to have the implementation of method 1. Same signature, void, method 1, no parameters, and then we have to derive statements here, or we just have to create something similar to this. This is implementing this. Of course, multiple statements is implementing something. Normally you don't have something empty, but because it's in the interface, we have to use it. And just so you see it very clearly, your class name, colon, and the interface or comma separated list of interfaces for multiple inheritance that you're going to want this class to derive from. And like I said, multiple functionality. You have an interface here that does something. Maybe you have something that's going to help you do a particular part of your class, and then you have another interface that does something else. So you're extending that class based on interfaces that are very, very organized. We'll see this later. We'll also see an example.